For National Electrical Code, or NEC, training, especially starting from scratch, there are several avenues to explore, including online resources, in-person training, and recommended books. Firstly, let's examine some online resources. The National Fire Protection Association, or NFPA, website provides access to the NEC itself. Their website is nfpa.org/codes and standards/all codes and standards/list of codes and standards/detail. Code equals 70. The NFPA is the organization that develops and publishes the NEC. This is the official source for the code, providing the full text and related information. Mike Holt's Electrical Academy is a resource that provides various training materials, courses, and resources related to the NEC. Their website is mikeholt.com. CodeSoft by Interplay Learning, found at interplaylearning.com, offers interactive, simulation-based NEC training. This can be a good option for hands-on learning. David Hess provides resources at electricaltradesecrets.com. Secondly, let's discuss in-person training options. Consider the International Association of Electrical Inspectors, or IE. The IE offers courses and certifications for electrical inspectors and professionals. Their website is ie.org/education training. ASFS. The National Electrical Contractors Association, or NEC, provides education and training programs for electrical contractors. Their website is necanet.org/education. The Electrical Training Alliance, or ETA, is a joint training program between NECA and the International Brotherhood of Electrical Workers, or IBU. They offer apprenticeship and training programs. Their website is electricaltrainingalliance.org/find-a-training-center/. Many local community colleges and technical schools offer NEC training programs. Check your local schools for available courses. Thirdly, let's discuss recommended books. The National Electrical Code, latest edition, is essential. Access it through the NFPA website, nfpa.org/codes and standards/all codes and standards/list of codes and standards/detail. Code equals 70. Mike Holt's Illustrated Guide to the 2023 NEC 7th edition is a valuable resource for understanding the code. This is available at mikeholt.com/illustrated guides. Code Calculations for the 2023 NEC 7th edition by Hankins is a helpful guide for performing electrical calculations required by the NEC. This can be found at pearson.com/us/higher-education/program/Hankins Code Calculations for Themenos 2023 NEC 7th edition /PGM 374805 HTML. It is recommended to start by studying the NEC Handbook, which provides an overview and context for the entire code. Additionally, attend industry events and workshops to connect with other electrical professionals and learn about best practices. Remember to gain practical experience by working on projects under the supervision of experienced electricians. NEC training involves understanding various articles and sections. Here are some examples of key areas that are typically covered in NEC training and that you will want to research. Chapter 1 of the NEC covers general requirements, including the scope of the code, definitions, and rules for electrical installations. Article 90.1 describes the purpose of the NEC, which is the practical safeguarding of persons and property from hazards arising from the use of electricity. Article 100 provides definitions of terms used throughout the NEC. These definitions are crucial for proper interpretation and application of the code. Article 110 covers requirements for electrical installations, including workmanship, equipment approval, and conductor identification. Chapter 2 covers wiring and protection, addressing overcurrent protection, grounding, and wiring methods. Article 210 deals with branch circuits, including the number of outlets permitted, voltage limitations, and conductor sizing. Article 220 covers feeder and service calculations, providing methods for determining the appropriate size of conductors and overcurrent protection for feeders and services. Article 230 covers services, including service conductors, overcurrent protection, and grounding requirements. Article 240 addresses overcurrent protection, including fuses and circuit breakers, and their proper application and coordination. Article 250 covers grounding and bonding, which are critical for electrical safety. This article outlines the requirements for grounding electrodes, equipment, grounding conductors, and bonding of metal parts. Chapter 3 covers wiring methods and materials, including raceways, cables, and conductors. Article 300 provides general requirements for wiring methods, including protection against physical damage and proper installation techniques. Article 310 covers conductors for general wiring, including conductor types, ampacity ratings, and temperature limitations. Article 314 covers outlet, device, pole, and junction boxes, conduit bodies, fittings, and handhole enclosures, including their proper use and installation. Chapter 4 covers equipment for general use, including appliances, motors, and transformers. Article 400 covers flexible cords and cables, including their allowable uses and limitations. Article 430 covers motors, motor circuits, and controllers, including overcurrent protection, motor disconnecting means, and motor control circuits. Article 450 covers transformers and transformer vaults, including overcurrent protection, grounding, and ventilation requirements. Chapter 5 covers special occupancies, including hazardous locations, healthcare facilities, and places of assembly. Article 500 covers hazardous locations, including classifications of hazardous locations and requirements for equipment installed in these locations. Article 517 covers healthcare facilities, including requirements for essential electrical systems and patient care areas. Article 518 covers places of assembly, including requirements for emergency lighting, fire alarm systems, and occupant notification systems. Chapter 6 covers special equipment, including electric signs, elevators, and electric vehicles. Article 600 covers electric signs and outline lighting, including requirements for disconnecting means, overcurrent protection, and grounding. Article 620 covers elevators, dumbwaiters, escalators, moving walks, platform lifts, and stairway chair lifts, including requirements for disconnecting means, overcurrent protection, and control circuits. Article 625 covers electric vehicle charging systems, including requirements for charging equipment, wiring methods, and overcurrent protection. Chapter 7 covers special conditions, including emergency systems, fire alarm systems, and low-voltage systems. Article 700 covers emergency systems, including requirements for emergency power sources, transfer switches, and emergency lighting. Article 701 covers legally required standby systems, including requirements for standby power sources and transfer switches. Article 702 covers optional standby systems, including requirements for generator sets and transfer switches. Article 760 covers fire alarm systems, including requirements for fire alarm control units, initiating devices, and notification appliances. Chapter 8 covers communications systems, including telephone, radio, and television. Article 800 covers communications circuits, including requirements for telephone, radio, and television wiring. Chapter 9 contains tables and examples for calculating conductor sizes, raceway fill, and other electrical parameters. These tables are essential for properly designing and installing electrical systems. Annexes are located at the end of the NEC and provide additional information and guidance on various topics. These annexes are not part of the enforceable requirements of the NEC but can be helpful for understanding and applying the code. The NEC also uses informational notes. Informational notes are included throughout the NEC to provide additional information, guidance, and explanations of the code requirements. These notes are not part of the enforceable requirements of the NEC but can be helpful for understanding and applying the code. Voltage drop calculations are important to ensure that voltage of the equipment is within the required tolerance. Conductors must be sized properly for the load they will carry. Grounding and bonding ensures a low impedance path for fault currents and helps to minimize electrical shock hazards. Overcurrent protection devices such as fuses and circuit breakers protect conductors and equipment from overloads and short circuits. The NEC specifies minimum clearances for electrical equipment to ensure safety and proper operation. Equipment must be listed and labeled by a recognized testing laboratory. Wiring methods must comply with the NEC requirements for the specific application. The NEC requires that electrical systems be installed in a neat and workmanlike manner. The NEC contains requirements for labeling and identification of electrical equipment. There are numerous tables in the NEC that provide information on conductor ampacity, conduit fill, and other important parameters. Understanding the definitions in Article 100 is critical for proper application of the NEC. When beginning an NEC training program, consider the following strategies. Firstly, focus on understanding the basic principles and concepts of electricity. Secondly, review the definitions in Article 100 of the NEC to ensure a clear understanding of the terms used throughout the code. Thirdly, study the general requirements in Chapter 1 of the NEC, including the scope of the code and rules for electrical installations. Fourthly, familiarize yourself with the wiring and protection requirements in Chapter 2 of the NEC, including overcurrent protection, grounding, and wiring methods. Fifthly, learn about the different wiring methods and materials in Chapter 3 of the NEC, including raceways, cables, and conductors. Sixthly, study the requirements for equipment for general use in Chapter 4 of the NEC, including appliances, motors, and transformers. Seventhly, explore the special occupants covered in Chapter 5 of the NEC, including hazardous locations, healthcare facilities, and places of assembly. Eighthly, investigate the special equipment covered in Chapter 6 of the NEC, including electric signs, elevators, and electric vehicles. Ninthly, review the special conditions covered in Chapter 7 of the NEC, including emergency systems, fire alarm systems, and low-voltage systems. Tenthly, become familiar with the communication systems covered in Chapter 8 of the NEC, including telephone, radio, and television. 11th, use the tables and examples in Chapter 9 of the NEC to perform calculations for conductor sizes, raceway fill, and other electrical parameters. 12th, refer to the annexes at the end of the NEC for additional information and guidance on various topics. 13th, pay attention to the informational notes throughout the NEC for additional information and explanations of the code requirements. A basic understanding of electrical theory is crucial for NEC training. Here are some concepts. Firstly, voltage is the electrical potential difference between 2 points, measured in volts. Secondly, current is the flow of electrical charge, measured in amps. Thirdly, resistance is the opposition to the flow of current, measured in ohms. Fourthly, Ohm's law states that voltage equals current times resistance, or volts equals amps times ohms. Fifthly, power is the rate at which electrical energy is transferred, measured in watts. Sixthly, the power formula states that power equals voltage times current, or watts equals volts times amps. Series circuits have components connected in a single path, so the current is the same through each component. Parallel circuits have components connected in multiple paths, so the voltage is the same across each component. Conductors are materials that allow electricity to flow easily, such as copper and aluminum. Insulators are materials that resist the flow of electricity, such as rubber and plastic. Alternating current, or AC, is an electrical current that periodically reverses direction. Direct current, or DC, is an electrical current that flows in one direction only. Transformers are used to increase or decrease voltage levels in AC circuits. Capacitors store electrical energy in an electric field. Inductors store electrical energy in a magnetic field. Diodes allow current to flow in one direction only. Transistors are used to amplify or switch electronic signals. Integrated circuits, or ICs, are complex electronic circuits on a single chip. Digital circuits use discrete voltage levels to represent binary data. Analog circuits use continuous voltage levels to represent analog signals. Microcontrollers are small computers on a single chip that can be programmed to control various devices. Understanding these fundamental electrical concepts will provide a solid foundation for NEC training and help you apply the code requirements effectively. Consider common NEC violations to avoid: using undersized conductors, failing to properly ground equipment, improper use of flexible cords, exceeding the full capacity of raceways, improper installation of overcurrent protection devices, failure to protect conductors from physical damage, using non-listed or non-labeled equipment, failure to provide required working clearances around electrical equipment, improper wiring methods, and failure to follow manufacturer's instructions. Let's consider the resources mentioned earlier in more detail. National Electrical Code, or NEC, website, NFPA. org/codes and standards/all codes and standards/list of codes and standards/detail. Code equals 70 is the official source. The NFPA website provides access to the latest edition of the NEC as well as related information and resources. This is the primary source for understanding and applying the code. MyColt Electrical Academy, MyColt.com provides various training materials, courses, and resources related to the NEC. MyColt is a well-known expert in the field of electrical training, and his materials are widely used by electrical professionals. CodeSoft by Interplay Learning.com offers interactive, simulation-based NEC training. This can be a good option for hands-on learning, as it allows you to practice applying the code in a virtual environment. Electrical Trade Secrets by David Hayes, electricaltradesecrets.com provides practical tips and insights into the electrical trade. This website can be a valuable resource for learning about real-world applications of the NEC. International Association of Electrical Inspectors, or IEIE. org/education training. ASPCS offers courses and certifications for electrical inspectors and professionals. The IE is a leading organization in the field of electrical inspection, and their courses are highly regarded. National Electrical Contractors Association, or NECA, org/education provides education and training programs for electrical contractors. NECA represents electrical contractors and provides resources for their professional development. Electrical Training Alliance, or ETA, Electrical Training Alliance. org/find a training center/ is a joint training program between NECA and the International Brotherhood of Electrical Workers, or IBU. They offer apprenticeship and training programs for aspiring electricians. MyColt Illustrated Guide to the 2023 NEC 7th edition, MyColt.com/illustrated guides, is a valuable resource for understanding the code. This guide provides clear explanations and illustrations of the NEC requirements. Code calculations for the 2023 NEC 7th edition, Pearson.com/us/higher education/program/Hankins code calculations for Themenos 2023 NEC 7th edition /PGM 374805. HTML is a helpful guide for performing electrical calculations required by the NEC. This book provides step-by-step instructions and examples for calculating conductor sizes, raceway fill, and other electrical parameters. Remember, continuous learning and staying updated with the latest edition of the NEC are crucial for success as an electrical engineer. By utilizing these resources and dedicating time to studying and practicing, one can develop a strong understanding of the NEC and excel in one's career.